uh, Day in the Life of series. So, with this, we aim to bring industry leaders, experienced individuals, and subject matter experts to share their journey with us and walk through what a day in their professional life looks like and what are the things that we could learn from them to do expedite in our career in that direction. So, without further ado, let's welcome the first speaker of the series, Chirag Satish. Chirag, warm welcome to our Google Developer Student Club's community. Thank you so much for sparing your time. And thank you for joining all the way from California. I
Thank,
assume you must have a very busy evening and so glad you
uh,
could join us.
thank you. Happy to do this. Thanks for the invite.
Thank you so much.
Okay. Should get
Chirag,
started?
the stage is yours. So
Okay.
please
Thank you.
walk us through your journey.
Right. Yeah. Thanks. So I have a few slides which I've prepped to just go over the organization I'm part of, the kind of work we do, and also sort of quickly go over the recruitment process at Google. I'm sure this is not new. The recruitment process, especially, is not news to you folks, but I thought just do it nonetheless. Next slide, please. So a little bit about me. So I joined Google about 2 years ago, straight out of grad school. Fun fact: I did my master's from Penn State, which is about 3 hours away from most of you folks on this call. So pretty familiar with the Pennsylvania area. So yeah, I'm a pandemic Noogler. That's what we call ourselves. Noogler is a new Googler, and yeah, a lot of us joined when the pandemic was ongoing, and we joined remotely, and things were weird. But yeah, that's that. And I work in the technical infrastructure org. So the organization as a whole builds the infrastructure that powers all of Google services. So it's like the size of the org is almost comparable to like a medium scale software company, because we handle everything there is that is to do with infrastructure, the software, the hardware, the networking, all of that. And yeah, a cool fact about the picture that I've posted here. This was about 2 or 3 weeks ago here at the Google office in Mountain View, where they had the Formula One car, and they had the McLaren Formula One drivers come in and do like a fireside chat. So it was, the choice was either this photo or like a photo of me eating lunch at Google. I thought, this narrowly wins. So anyway, let's move on to the next slide. Next slide. Yeah, so a little bit about the systems and services infrastructure at Google. As I mentioned, our organization, handles and controls all of the infrastructure deployed at Google. So, you use any Google-powered service. At the end, it's hitting one of the servers that we've designed from scratch and deployed the software and run maintenance on it. So yeah, so it's like the scale at which Google's infrastructure operates is, even to me, is breathtaking. Every day I look at some of the stats around the amount of computing power there is, the amount of storage there is, and the intricacies of all these layers to run reliably. You never see Google search down, right? Like that's I don't know how that happens. Like honestly, even that to me is fascinating, like the way all these infrastructures and services run together. Next slide. Yeah, so under the umbrella of S2 Infra, we work on networking, computer architecture and hardware design, the distributed systems and storage, kernel and system programming, you know, uh, optimizations in terms of the Google software stack, and so on. Specifically, I'm involved in the computer architecture and design space. So this is always a little confusing because I've studied computer science all my life and I'm now involved in hardware design. So I'm not involved in like the sort of the fine level details. It's more like what should the system specifications be? And if is the system that we have designed good enough to handle the workloads? Where is the limits? What is the cost of developing such a system? because if you want more performance, you pay more, but do we really need that? So there's a lot of trade-offs there, and that's sort of the area I work on. And to help inform all this, we do a lot of analytics to see what the fleet workloads are, right? Who's the user which is growing the most? How do we, how do we optimize certain software stacks so that it reduces our cost? So these are the kind of things I look at on a day-to-day basis. And if you're interested in anything in computer systems, our team is hopefully still hiring. And you know you can look at the career portal and um, apply. Next slide, please. Yeah, so just quickly going over the interview process. For the full-time roles, we have 1 to 2 phone screens. Before we used to have 5 virtual interviews, now it's 4. And then after you've done your interviews, then there's like a team matching process wherein your recruiters are, basically your best friends at that point, where they take your take your interview packet, as we call it, which includes your resume, your interview feedback, all that kind of stuff, and takes it to different teams who are hiring. And then you have fit calls with hiring managers. And then once you and the hiring manager feel there's a match, then you go into like negotiations for your pay and all that, and you finally get an offer. And then and then this is one of the coolest things, because after all this is done, you get an email from onboarding, which has this sort of, hey, 20 days to your first day at Google, and it keeps counting down. So when I got that email, I used to go there every day saying, oh, 20 days, 19 days, 18 days. And then on the day you join, it's like, hey, today's the day. So that's always a cool sort of a thing with the whole recruitment process. Next slide, please. Yeah, so with the phone screens, if you're interviewing for software engineering roles, it's going to be coding questions, algorithms, data structures, all that good stuff. And then you're going to have one behavioral interview in your virtual on-site interviews. Sometimes you have the choice of doing a domain-specific interview. Let's assume you're a domain expert in the Linux kernel. You could potentially do a kernel interview where you're asked questions about things related to the kernel. And if there's any PhD students in the audience, it's pretty much the same sort of recruitment process for you folks, except maybe the expectations are a little higher. But it's the same thing. I think that's the end of the slides, right? Oh, okay. One more slide. Yeah, on the non-technical interviews, yeah, behavioral interviews, if you go on Lead Code or something, or if you've seen any sort of Amazon leadership principles, it's on that same sort of it's like that, except it's not as intense. It's all about getting to know if you're a good fit for Google. We call it the Googliness and leadership interview. So it's related to your experience and how you handle problems and day-to-day situations. So that's about the behavioral interview.
That is so awesome. Essentially, the entire availability, performance, and the scale at which we see Google services is dependent on your team. So that's
Oh,
amazing. The
not all,
scale is
yeah.
amazing.
Our team plays a small role in that, but it's a lot
That is
of people.
still great. That is
Yeah.
still great. I think this is really, really awesome. What essentially will a day in the life of your role looks like?
Yeah, so that's a good question. So the team I'm part of, you can think of us as consultants in the technical infrastructure team, in the technical infrastructure org rather. So what we do is we work with different teams to ensure that whatever product they build is the best for the Google for the entire Google stack, right? To give you an example, I'm sure all of you are aware that Google builds our own servers, our own storage servers, storage appliances, and whatnot. So let's say AMD or Intel or someone comes up with this brand new super powerful processor, right? So the CPU is just one of the elements of building the whole server, right? So what our team does is, we know the specifications of the server, right? We do a lot of analysis to see, if this server coupled with, uh, you know, X amount of DRAM with X amount of NIC bandwidth, and we deploy it in our infrastructure, what is that going to change, right? Is it going to reduce our cost overall? Like, for example, since we have a more powerful CPU, maybe we can run more jobs in there, right? So these are the kind of analysis we do to help inform our partner teams that, hey, okay, this is a good design. We look at the design space and say, hey, this is a good design. We can try and build it. So then, they are the experts in actually building that platform. So once they have like a prototype, they come back to us and we have that machine and we run a bunch of benchmarks, right? To see how they to sort of extrapolate how they would actually perform in the Google data center, right? So if there's any sort of issues there, we run into some performance issues, then we work with the vendors, or we work with folks all around to sort of debug it and make sure that throughout the entire development process, at the end of it, we have a product that is a good fit for Google, and it continues to power all the services. So that's what our team does. So again, back to your question of what my day looks like. So since we're not involved in the entire development process, there are bursts, right? If it's the initial phase, there's a lot of work where we have to pull in all the data to sort of fix the design point for the system, right? And then once they come back with a prototype, we run all sorts of benchmarks, analyze the data, see where the bottlenecks are, debug it, and then it goes back to them. And finally, when the final sort of end product is there, we do more tests, and then it goes into full production entry, wherein it's deployed globally in the data center. So that's one aspect, which is new product introduction. The second thing that we do, and is arguably very important in today's sort of business climate, is optimization, right? So Google has a very sophisticated telemetry system wherein we log a lot of stuff, like right down to we take like CPU counters to look at how jobs run at the CPU level, all the way till the user sort of, hey, what is the latency that users are experiencing and whatnot. So there's like a huge range of telemetry that we have access to. And the other thing that we do in our spare time between when the NPIs are underway, NPI is new product introduction, by the way. So when they are underway, is look at this stack and try to optimize it, right? So one example I can give you is, can we lower the power that the CPU uses? So lowered power means, it's less electricity expense to Google. Can we lower the power? If you lower the power, that's fewer instructions that the CPU can execute, et cetera, right? And can we still sustain our workloads and adhere to all our SLOs by lowering the power? And are there some workloads that are a good fit for these kind of optimization? So there's a lot of work there to sort of tinker with the knobs to make sure everything runs more efficiently. And the third one is kind of like R&D, which is innovation. One example is TPUs. Fun fact is TPUs actually came out of the team I work with. So it again sort of started with the discovery that, hey, Moore's law is slowing down and we're not getting improvements in CPU that we used to, right? And at this rate, and they also saw that the ML workloads are constantly growing. And some of the folks who are still in our team, by the way, they looked at it and they realized that, hey, at this rate, it'll be very, very, very expensive to run ML workloads on CPUs and support the existing server workloads. So what they did is they sort of went ahead and designed TPUs, right? TPUs are tensor processing unit, and they are dedicated machines which just run ML applications, right? So those are the kind of innovations that have come out of just looking and pouring through the data, looking at trends, looking at costs, and making sure that Google can operate efficiently and in a cost-effective manner. You're muted, Raga.
That is just awesome. I was so awestruck with all the work you do, and the scope for innovation in this zone is so high. It's no more monotonous, same work we do day in, day out. It's just so innovative. That's really awesome. And now I really have to ask this question. Have you been to Google data center?
Yeah, no, the sad news is I haven't.
Oh,
I really want to though. So the thing about visiting Google data centers is you need a lot of clearance, right?
absolutely.
So and I don't know if we have any data centers around the Bay Area, like the big ones, because I know the big ones are kind of in like North Carolina and Atlanta and those kind of sort of the middle of America. But that's certainly on my bucket list to go and actually see the products we build, you know,
In
running
action.
away. Yeah.
Absolutely. Me being an InfoSec professional, I'm fascinated by the seven-layer security that they implement for all the data centers. That is just mind-blowing.
Yeah.
And the fancy equipments that is there apart from the servers itself. Now, the
Uh-huh.
servers, you've explained it in detail. That looks fascinating. But there are so fancy equipments to even navigate through the vastness of the data center. That is just
Right.
awesome.
Yeah, yeah. I mean, yeah, the scale and yeah, security. That's another sort of very interesting uh, sort of the way it's implemented. We have security baked in at so many levels, right? Security is a huge consideration even when we build a new server platform, right? It's almost like if there's a feature that is going to cost us some money, but is going to make the entire Google ecosystem safer, we do it, right? Safety is at the core of everything, like encryption and root of trust, hardware root of trust, and all that kind of good stuff is like baked into it. And even like for example, uh, they have really they have many firewalls that prevent employees from getting access to personally identifiable information. I cannot just root access anything in prod and try to read the disks. It's like nobody can, right? It's that well baked into the whole ecosystem.
Absolutely. Now we are at par relieved with using Google services. Not that we weren't earlier, but then hearing from you, the confidence is increased.
That's great.
So, if I may dig a little deeper on your curriculum itself at Penn State, so what are the subjects that help you get onto this role, or if there is something you would like to do differently, what are the subjects you would pursue to kind
Right.
of help you expedite in this role?
Right. Yeah. So at when I joined Penn State, um, I wanted to sort of experiment a little because straight from grad school, I'm hoping there's a few more people like me, but I didn't really know what I liked, right? Because in grad school you're exposed to a bunch of stuff and like it's fine, like you chug along and there's nothing really that spoke to me in my undergrad. So in grad school I took the opportunity in my first year to sort of try different things. I took a few ML courses, a few systems courses. Yeah, basically these two things to sort of figure out what I liked. And what I discovered was I really enjoyed computer architecture, and that's sort of the direction I did my thesis in. So I had to do a thesis. So I did some work on that, and so that is what brought me to this kind of a field, right, where we are pretty low in the stack, look at everything at the system level, right? So that's what drove me towards this current role. But one thing that I'm noticing is that irrespective of the field that you're in, um, statistics and machine learning is becoming critical in whatever we do. For example, right, like you know, we get so much telemetry from the services now that that's almost impossible to come up with insights just by looking at the data, right? Like you need that statistical knowledge and machine learning expertise, or even some sort of knowledge of ML modeling to sort of make sense of the data and sort of make everything faster. Instead of you sitting pouring through lines and lines and lines of data, you can sort of leverage ML to do it for you. And ML also unlocks plenty of optimizations. Simple example is just scheduling jobs on Google servers, right? That is a very very hard problem. We have different machines with different capacities and different jobs which require different resources at different times of the day, right? How do you schedule those jobs and make sure they run and they don't evict other jobs, and the servers, the users are served? That's a very difficult problem, and that's where machine learning has helped sort of optimize this whole scheduling of jobs onto servers. So that is the direction that I potentially want to look at more, to build my skills in the ML space, so that you can contribute more.
Absolutely. And uh, did you have to pursue any certifications in order to stand out from the crowd?
Um, so certifications, not really. Again, I didn't. Um, I didn't do any certifications. I stuck to the curriculum and uh, used LinkedIn, all that kind of good stuff when it comes to recruiting. LinkedIn, reach out to people, find out people, reach out to people who you actually know, and they can really help you sort of. They'll really help you, help connect you to the right uh, sort of recruiter, right? So from what I see, that is sort of the biggest problem, is that whenever you apply to a job online, right, it's kind of like a black box. You don't know what the recruiter who's picking up your resume is looking for, right? And that brings, and then you this has happened to me multiple times, right? You get that rejection notice. I'm like, why, right? So I think one of the things that I would suggest you folks to actually focus on is reaching out to the right people, and then focusing your energy on that, as well as interview preparation, obviously, because I do know that there's a tendency for you to. I see these stats all the time. There's people who say I applied to 170 companies and I got responses from 10 and interviews from 3 and I got one job offer. Right? That ratio is ridiculous if you think about it. So I would say 140 applications, pretty good. Maybe drop that down to 70 and spend some time, reaching out to people, posting on LinkedIn, right? That's the best way, right? If your post does go viral or it reaches a lot of people, that's great, right? You reach out to people, just post on LinkedIn, and then eventually you'll reach the right recruiter, and then you sort of go from there.
Absolutely. So another question for me that kind of even is in minds of many of us are, "Mm, is it easier to get in as an intern, and how hard is it to get in as a full-time employee? Because I know your experience with full-time interviews and
Internship, yeah.
would you do the other way around?
Oh yeah. So this is again my personal experience. It does not reflect the reality. It might be different, but so internships I really struggled with, right? Because what you need to understand is internship positions are kind of limited. They're actually very very limited, and if you're a non-PhD student, you're kind of in the bucket with everyone else, right? So the competition is kind of intense, and and you know uh, that makes it a little difficult, and I found that personally as well, like very 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 difficult to get an interview for an internship. But for full-time roles it's much better, especially if you apply closer to when you graduate. This is another thing that many folks do is, say you're graduating a year from now, you start applying to full-time positions now. That's not the best of times to apply, because the recruiters is just going to see your graduation date and like, okay, they're graduating in May of next year. That's months away. So you can find a candidate now because they're looking for people now, right? So if I'm not saying do not apply, but I'm saying, have your expectations, right? You're going to get more callbacks and more opportunities the closer you apply to graduation. And of course, for full time, it's easier. The competition is obviously still crazy, but you can stand out as a master student with, you completed 2 years of or 1 year of masters along with your undergrad. So you definitely stand out then. So I would say, full-time positions are easier comparatively.
That's an interesting take. I thought the internship positions were easier to get in now. That's
Yeah,
really good. It's assuring. It's assuring to many of us. So thank you for that.
yeah, and more than that, like be patient throughout the entire sort of process. It is demanding. It's going to take a lot of energy, right? Completely understand it. Have been through it, right? Just focus on your core skills. Keep building it, and do not get disheartened. Something you'll find the right fit.
Absolutely. So we have 15 minutes with us. Audience, you have any questions for Chirag, feel free to drop it in and I'll be more than happy to direct to him. Or if you'd want to, unmute yourself, ask the speaker itself, that's great. So go ahead, either ways. So I see Akshay Kumar Gupta has one question. So Akshay, do you want to unmute and bring it to the
Um,
table?
yeah, thank you. First of all, hi, it was an amazing talk. And I'm also from Penn State University. So we are
Oh,
Penn State, right?
awesome.
Yeah, we lost with Ohio this weekend, so not very good. Anyway,
Yeah.
so anyway, the question I wanted to ask was about the system design interview.
Yeah.
So when someone asked me to design a system for, say, something like Amazon or maybe even a Google or something,
Mhm,
now what I see is I have two options. One is to go through what we study at Geeks for Geeks. That's the N-layered architecture,
mhm,
the standard architecture, right? And other is to go somewhere in that Kubernetes container orchestration types, or
mhm,
go a message brokering and the advanced level architecture, which are
mhm,
actually being used in the industry now. Now,
mhm,
N layer is something which has been done to death, and nowadays everyone is doing microservices and things like that. So,
mhm,
but again, if I go to microservices path, the thing is I will be grilled to death because again, it's very, very complicated. So, what do you
mhm.
think? How should we approach such questions? Should we go with the traditional one or the new ones?
Right. Good question. So for system design interviews, um, so the thing is, when you do propose a solution and whatnot, right? The most important thing is that you understand the how your solution fits into the problem, and if you can do the pros and cons trade-off, right? That's the main thing. It is impossible for anyone in 45 minutes to build a solution to, let's say, Google search, right? You cannot do that. It's just not possible. The main thing that every interviewer is looking for is if you understand, how your solution works for the problem, right? It doesn't have to. You can definitely say, hey, this is a drawback, and maybe the scalability is not that great, but hey, the latency is really good with this solution, and if that's what the customer is looking for, this is a good fit, right? If you're able to to talk about such aspects of it, that's great. And even if you're grilled about your microservices solution or whatnot, right? If you can defend it, or even like sort of admit to shortcomings and show that you identify it, that shows that you have great insight of system design. And given a problem, obviously of a much smaller scale than this, you will be able to analyze the trade-offs and come up with the right solution.
All right, that makes sense. Thank you.
Thank you for that. Anybody else? Do you have any questions?
Hi, I have a question.
Go ahead.
I'm also a Penn State. I'm a PhD student in computer engineering. So you previously told that you analyze architectural like counters and etc. Do you use architectural profilers for that? And
Yeah, we
yes,
do use
like
like
are
Linux perf.
they, if yes, are they public ones or Google specific ones?
Right. So yeah, good question. So we have a combination of both. So it depends on what you're trying to do. If you're looking to get data about real production jobs, then we have internal Google sort of telemetry, which gives us this data that is designed so that we don't want to affect other jobs running because we want to collect bunch of counters from the CPU and stuff like that, right? But if we are doing sort of a single node experiment where we just have a prototype and we want to grab the counters, we don't really care about how different jobs interact and SLOs and things like that. Then we use like open source tools and uh, you know all that to sort of get the information. So it depends on the situation that you're looking to answer.
Are they similar to like Intel's VTune profiler and stuff? Like
Oh
top
yeah.
Okay.
They're very similar, right? It's
Okay.
not the learning curve is not steep at all.
Okay. Thank you.
No worries.
Amazing. There is a better representation from Penn State University. I hope you're happy now. That is cool. Okay. Okay. I see another question on chat. Thank you so much for the session. I really got to know some new insight. Could you please share this question saying, are there any internships available during the month of December to Jan? So you're looking for winter internships. So is there anything from Google side that is offered that you are aware of?
Hmm. If it's there on uh, Google/careers, then it's there. So I mean, if you're looking for internships for this year December, it's probably a little late. It's already November, so yeah, the career portal is your best friend if you're looking for positions.
Let me.
I have a hand raised, Ishita.
Thank you for the recognition. Indeed, it was really good session, and I think the kinds of opportunities which you have in your team look pretty good. So I was curious, like, do we have any analytics-based opportunities for full-time grads? Considering I'll also graduate in May, though I'll wait as per your advice. But yeah,
No, I'm becoming accountable for the careers of everyone. Just kidding. No, yeah, with analytics, yes. Okay, that's a great question. So we have a dedicated data science teams across Google. So I work primarily on storage servers, and storage products and stuff. And just for storage, we have an entire analytics team dedicated to sort of optimizing the storage stack. So one of so we do so one of the works that to give you an example of the kind of work that uh, the storage analytics team has been up to is they are trying to use so whenever there is an IO request sent to a hard disk, right? uh, uh, we it is impossible for us to log all the IO requests sent to all the HDDs, right? Because there are so many HDDs, and every single sort of 1 MB file read request or write request cannot be logged, right? That's going to take a lot of storage, and it's going to affect the actual SLOs of the storage server. So what we have is kind of a downsampled uh, sort of IO database, wherein it just samples a subsection of all the IOs that Google sees in its in all the data centers every day, right? So we have a downsample. So what the storage analytics team is trying to do is build a model to take the downsampled IO traces and sort of extrapolate what the full sample for that disk is going to look like, right?
okay.
So that's one of the examples, right, that the storage analytics team tries to do. The second thing that they do and they work on a lot is placement. Obviously, in a distributed system, files are sharded, and the shards are divided into chunks, and the chunks are placed in different servers, and you have to ensure reliability. So you do some sort of replicated or erasure encoding and things like that. So when it comes to files like this, the data analytics team analyzes sort of the placement patterns of Google's file system, and then they try to get insights based on that, and they improve the sort of placement policies uh, to make sure that the chunks are increased in their availability, for example, right? So that one of the things you can, I mean, this is a hypothetical idea, is you can look at the failure rate of different disks, right? And you can say, hey, this chunk seems like it's more likely to be accessed. So let me put this on a disk which has a better reliability. And then you have some sort of cold data, like some sort of YouTube shorts that I upload today saying, hey guys, I gave a talk at Google Developers, whatever, which probably 20 people are going to see, right? Which is not going to be accessed again. And it's probably okay for me to put that in a disk with a higher failure rate. Obviously, it's going to be replicated so that, if this disk goes down, it's okay, you can reconstruct the data. So that's kind of the storage analytics side of things. And again, there are these kind of analytics teams spread across Google, and their job is to just look at the data, build models, get insights, and optimize the whole stack.
Got it. That's really interesting. So maybe a small follow-up to this. Since we have analytics teams across all the, I would say, fields, like storage being an example, do you think that domain knowledge of the storage or whatever area we are in would be required, or is it just analytics as a prerequisite before joining?
Right. So it's, your analytics skills are definitely important, but it's also good to have some domain knowledge. I mean, if you want to be a data scientist in like an infrastructure team, some knowledge of the infrastructure is good. But then again, the caveat here is sort of whatever you learn in, say, your grad school, right, is the scale is, you cannot compare it to Google. So it's almost like you come here and you relearn, right? So
Right.
I know my talk has been very systems oriented, but if you want to look at say application development, right? At Google, writing code is so much different from how you write code in say grad school or in grad school, right? There are a lot of rules that you need to follow, a lot of internal libraries that you use, and a lot of things that you use outside that you cannot really use inside Google. So you relearn a lot of it. So if you're curious and want to learn, you can easily pick it up by just talking to people, poking around the code base. And that's the other thing about Google's code base. It's a single repository. So I can go in and look up there are obviously a few things which are not accessible to everyone. But if I'm interested in knowing how Google Drive's backend interacts with Google's file system, I can easily go pull up Google's Drive's directory or talk to somebody from Google Drive, and they'll point me to which file to look at that interfaces with Google's file system. And then I can learn more about how Google Drive's backend is interacting with the distributed file system, right? So if you're curious, you can always poke around and learn more.
Got it. Thank you so much.
All right. I think we're top of the hour. So thank you everybody for joining. And thank you so much, Chirag. This was really amazing. And we couldn't thank you enough for sparing time and educating all of us. So thank you so much. And
Thank you.
folks, if you're fine, we'll just spare a minute to memorize this moment. I'll just take a screenshot. So it's say cheese. Thank you so much. And we look forward to staying connected with you, Chirag. Thank you so much. And let's stay in touch.
Yeah. Good luck,
Have a
everybody.
nice evening.
Thank you.
Thank you.
Thank you.